Okey, Assalamualaikum warahmatullahi wabarakatuh. Hai, selamat petang semua. Okey, hari ni sihat? Ada lagi test tak selain daripada test saya? Bila lagi test?
Esok.
Oh, esok ada lagi. Esok test apa?
Programming.
Okey, dengan Dr. Syamil, Dr. Syikin Okey, tak apa. So, hopefully today we can finish early so that you can focus on preparing for your test tomorrow. Okay, so we are going to discuss tutorial 7, and this is about the energy balance of the open system. Okay, so before that, I want to remind everyone again that our test will be next week, which is on 16th of June, on Thursday, like this, at time 2 to 4. Well, actually, test will be only one in the 1 jam 15 minit. 1 hour 15 minutes only. So we start at 2, we finish by 3:15. And the venue, similar like the venue that we had our first test, which is at Dewan Perperiksaan 1. And the topic that will be covered is until the energy balance of the closed system. So until the tutorial last week lah. But just want to highlight a few things. Nanti saya akan ni juga mention sebab I'm gonna give you some of the tips for the test during this tutorial session. Okay, so just ni lah, make sure that you stay alert and ni lah. If you have any question, please ask. Okay, so for the test, basically what been covered daripada lecture, basic concept of thermodynamics is just theory. Properties of pure substances, and I really hope that you are now familiar on how to find data or information from the steam table, from the property table. Okay, we have as what I give you, we have like a lot of tables, but the one that we are going to refer to, only 3 tables, which is A4, A5, and A6 for the time being. Okay, so please try to familiar yourself with the way to extract information from the tables, or else during the test, if you are not really familiar, you are going to take some times to get all the data and so on. And let's just go through first with the the property of your substances. The most important thing is just to know how to get to find value from the table. Okay, and nanti kita akan buat sedikit example. Okay, I just want to know whether you know which table to refer to, because this is so very important for you to know, because or else you will get confused, then you will not going to be able to get the right information from the right table. Okay, especially when it comes to A6 table. Okay, because this is superheated. For A4 and A5, I think it's very straightforward. What you need to do is, if you have temperature, then you can refer to A4 for the saturated water. If you have A5, then you can refer to, if you have pressure value, then you can refer to the A5. But what about the superheated water? And we'll discuss it by today. And then we have enthalpy, open system, closed system. For the closed system, basically what you need to do is just to list down the energy balance first. Delta P, the change of internal energy plus the change of kinetic energy plus the change of potential energy is equals to Q plus W. Okay, so that's about the closed energy. form of energy, you also need to know how to calculate all the type of form lah. We have three type of form: internal, kinetic, and also potential energy. Okay, so you need to know how to calculate each of these type of energy. And please don't get confused, okay? Because I think this is also something that you need to be very alert. Okay, saya lukis kat sini. Okay, especially like this, So we have a KE in which the unit will be in joule only, okay? And then we have E dot, EK dot, or KE dot, KE dot, which means that it will be in rate, joule per second. It can be dot or can be in the small letter, KE. Similar like if you are talking about the velocity or mass, or let's say uh, for the internal energy and so on. Okay, if it's a small u or u big U with dot, then this is what we call as the rate. Okay, so you need to know that it will be having time as a function of the joule. Okay, so just because when you do the calculation, you need to make sure that all the unit will be, you know, it will be synchronized so that you can get the final answer, and you can know whether the answer is right or wrong. And also we have the sorry, terbalik pula. Sorry. Betul lah. Okay. And then we have caret, something like this. Oh sorry lah, silap lah. Okay. Sebenarnya tengok, I pun confused. Not small. Okay, small is referring to ni. Okay, for the flow rate or for the something related to rate, we will have dot. But when we want to have something in the function of the kg, it can be either, let's say, ek, or it can be ek. It can be in a small letter, or let's say potential energy is with the caret, or it can be small pe, and so on and so forth. U is equals to small u, okay? So this is referring to the unit of joule over kg. So please bear in mind, this is all specific per mass, specific kinetic energy, specific internal energy, specific potential energy, specific volume, V O V kecil. Okay, so this is something that you're going to get in the steam table. It's all about specific, and the unit will be in joule per kg or kilojoule per kg. So what you need to do, if the question asks about rate, so you need to change from this unit to become this unit. Or if the question asks about just the normal kinetic energy, let's say, without any rate or any specific kinetic energy, so the answer will be in joule. Yeah, so this is something that you need to also familiar with. Okay, so this is for the form of energy. And then we have the other one is the energy balance for the closed system. I think the most important thing is to okay, no, this one. Okay, a work or power. Okay, so normally we term work can be either work or power. Dia punya ni. Okay, this should be plus. Sorry. Don't get confused. Sometimes if you refer to some of the thermodynamics punya ni, Q plus W. If you refer to some thermodynamic textbook, they will put Q minus W. But I think it's a bit confusing. The most important thing was to know whether it's plus or is positive or negative, depending whether the heat and the work, whether it's from the system or to the system. If it's from is to the system, then the value will be positive. If it's from the system, then the value will be negative. So if, as long as you kind of like grab this, I think it would be you can have you can, you know, at least get the idea on whether this is positive or negative, because this is also going to affect the calculation if you fail to put the value right correctly. Okay, but more or less this is the energy balance, this is the general formula that you need to remember whenever you do any question related to the energy balance. You need to list down this first, and then you determine which one that can be neglected. Most of the time for the closed system, if the question did not mention about anything about the height or about the velocity, then we can assume that the energy, kinetic energy and the potential energy will be equals to zero. So for the closed system, is more straightforward compared to the open system. And for the closed system, normally we refer to the internal energy. For the open system, normally instead of delta U, we are referring to delta H, enthalpy, in which, well, actually enthalpy is U plus BV, but because uh, we are referring more towards the just internal energy, so that's why for the open system, instead of delta U, we'll have delta H. Okay, so what else? Okay, one more thing, sorry. Okay, this also will be something that you will be asked in the ni soalan bocor ni. This is the tips that I'm going to give you. Mass fraction, or normally we just call it as quality. Quality of the steam, or quality lah. Selalu kita panggil quality X. Okay, so you need to know how to find X. Well, actually, it's just a mass fraction of the vapor over the total of the mass. But at the same time, you need to also know how to calculate the, let's say for instance, like, I want to know what is the specific volume, internal energy lah senang. I want to know the internal energy of this substance, of this substance, and we have vapor and also liquid. So how going to determine this? In the by referring to, let's say I got the value, the temperature is at 100 degrees C. So when we have the temperature, and we know that this is saturated, this is not superheated steam, so we know that this is referring to table apa? A4, A5 or A6? Anyone can answer?
A4.
A4, betul. Okay, so can you please go to table A4 and see what is the internal energy for 100 degrees Celsius? Let's just do it together. I'm going to give you tips, okay? If you don't want to do it now, you're going to have some problem when you want to answer the test one, okay? Ni dah bagi apa? Discount dah dibagi cara nak lihat. Okay, how much that is the internal energy? The specific internal energy for water and liquid? Dapat tak? Okay, let me just list down it here lah. Susah untuk buka ni kan. Okay, table 4. Table A4. Okay, so the internal energy at 100 degrees C, UF is 410 9.06. UFG, how much? Berapa? UFG?
2087.
7. Okay, what about UG? 25, 2506.
506.
Okay, thank you. All of this in kilojoule per kg, kan? So this is all specific heat, specific internal energy. Kilojoule per kg. So if the question asks, what is the internal energy of this substance, this mixture? How are we going to calculate this? Are we going to refer to UF? Are you going to refer to UFG or are you going to refer to UG? Which one? Anyone want to answer?
UG and UF.
You apa?
UG.
UG. Ada lagi yang cuba nak try jawab? Well, actually, because this is a mixture, so we cannot just straight away use all of this, yeah, UF or UFG or UG, because this specific internal energy is referring to the phase. Okay, so UF is flow fluid, so it's just referring to the liquid part only. UG is just referring to the vapor part only, and UFG is the different, yeah, 2506 minus 419, we got UFG. But when we are referring to the internal energy of the mixer, we will have to calculate like this. Okay, so nampak ni dekat sini. UF plus X, UG minus UF. Okay, saya patah balik kat sini ya. So if you are referring to the internal energy of the mixture, ya, mixture lah kat sini ya. It's UF plus X. X is the quality. So we need to know the quality first. And then this is the UG minus UF, which is UFG lah. Okay, so in order for us to answer this question, we need to know what is the value of X first. Let's say lah, okay, vapor ni dia cakap dekat dalam, this is a 10 kg punya mass, vapor is 30%, while liquid is 70%. So based on here, we can calculate the X kan. X is the mass of the vapor. 30% of 10 kilo is 0.3. And then 0.3 plus 0.7. So it's going to be equals to 0.3 lah. Okay. So let's say now we have the X already. So UF 41906 plus 0.3 times 2087. Please do the calculation. I don't have the answer. How much is the value that we're going to get at the end? How much?
$1045.16.
1045.16.
16.
Okay. So yeah, thank you. So that means that the internal energy that we want from this, the mixture, is this. Yeah, it's not straight away that you're going to get in the table A4. Okay, so I want you to have this in mind, clear in mind. Okay, because this is something that will be asked in the test too. Straight away I give you some tips. So you kena tahulah cara untuk dapatkan X, macam mana nak pastikan how to calculate this. Okay, based on this lah, I give you example for internet energy. I can ask you about specific enthalpy or specific volume, but more or less it's the same. It's the liquid part plus the X times the difference between the liquid and the gas part. Okay, so clear? Any question for this one? So this will be something that will be asked in the test 2. Not directly like this, but in the way you solve any kind of and the question, you will require to find something like this. Okay, clear? Okay, so just be careful with the X and lah. Okay, so something like this also you need to ni lah. Okay, sometimes I will also the X. Okay, the X can be either I give you you can determine the X by having the mass, but sometimes I'm not going to give you mass, but I'm going to, let's say, I'm going to give you in terms of the value. We have the U, okay, we have the U mixture, we have the UF, we have the UG. So find the X. So what you need to do is to do the rearrange balik this formula, okay? X is equals to U mix or U minus UF kan? Bahagi dengan UFG. Betul kan? So you can get X at the end. So maybe I can ask you something like this. Instead of directly using this formula, maybe I can just ask you to find X by asking you by giving you the other value. So what you need to do is to do, for instance, like this one kan. So see, ni X is equals to U minus UF over UFG. Okay, so akan dapat something like this. So please try the example 15.1 and try to understand. Or maybe I can ask question. Macam I want to ask question. Please draw a PV diagram and determine which part is the X. So awak kena lukis lah PV diagram. And then the curve, the dome. This is P, this is V. And then where is the X? Okay, so that when this is the region for the saturated liquid and vapor kan. So definitely the point will be something like in here. So you need to determine which is the point for the X according to the volume and the P. Okay, something like that. Okay, so clear? That's about the test 2. I really hope that you're going to excel test 2 because the topic that will be covered in test 2 is not that much. So hopefully at least you got more time to study. Okay. So we are going to proceed with tutorial 7, and this is for the energy balance of open system. Well, basically for me, I think open system and closed system, the way to solve the way to do the solution is more or less the same. It's just the matter for the open system. Normally, the for the open system, normally is have more Q plus W equals to delta. Okay, for open system, delta H instead of delta U, delta KE plus delta PE. Okay, for the closed system, bila kita bercakap, when we talk about closed system, there's no movement of the mass. When there's no movement of the mass, normally the kinetic energy and the potential energy will be considered zero. But for the open system, so this is like a process, okay? This is going in, this is going out. Okay, so for the open system, the volume inside will be, for the steady state, the volume inside will be constant, but there will be some mass in and mass out. So because of this can relate to some velocity. This is V1, this is V2, and also some changes in terms of the the height, which is equals to Z ataupun H or H. And this related to the kinetic energy and the potential energy. That's why, okay, and for this work is referring to the work of shaft. Okay, and that's why for the open system, using the more or less the same general equation, but maybe the calculation will be a bit longer because we have to calculate each one by one, all of this. But as long as you know how to calculate the potential energy, the kinetic energy, and so on, will be okay. Yeah. So we start with the first question. A boiler operates at a constant pressure of 15 bar. Okay. Tidak bagi dah. The pressure is 15 bar and evaporates fluid at the rate of 1000 kilogram per hour. Okay. So this is the mass flow rate. At entry to the boiler, the fluid has an enthalpy. Okay, so like I said before, in the closed system is about internal energy, but for the open system is more about the enthalpy. So enthalpy is 165 kilojoule per kg. This is enthalpy 1. And living boiler, the enthalpy 2 is 2200 kilojoule per kg. So determine the heat energy supplied to the boiler. Okay, from here, the first thing that you need to do is to list down this formula first. Okay, I'm going to, okay, let us do it together. Okay, so we have, this is question 1. Okay, we have delta H plus delta KE plus delta PE equals to Q plus WS. Why WS? Why not W? Because as what I mentioned in the lecture, work will be related to work, internal work as well as the shaft work, in which the internal work have been rearranged to be part of the enthalpy is U plus PV. Okay, so that's why here we only consider work of shaft. Okay, please do the revision back based on the video and the notes that I have given. Okay, so based on the question now, okay, so bila tu kita lukis, we have to draw in order for us to get more understanding and the clearer picture about the process. So this is the boiler lah. And then this is going in, this is going out. The mass flow rate is 1000 kg per hour. And also the pressure is 15 bar, kan? 15 bar. Okay, and then what else that we have? We have the enthalpy, H1. Why small h? Because this is per kg. So it's a specific enthalpy. It's specific enthalpies, 165 kilojoule per kg. And then H2, we have 2200 kilojoule per kg. Okay, so these are all the information that we have. And then based on here, we don't, there's no velocity had been given, so we assume that the kinetic energy is 0. And also there's no difference in terms of the height, so we consider that potential energy is 0. And there's no kinetic or mechanical movement whatsoever, turbine, shaft, whatever. So we consider that work shaft is also 0. So this lead to only delta H equals to Q. And the question asks how much is Q? So, senang je lah macam ni. Okay. So, delta H, sorry. So, tulis bawah ni lah. Q equals to, because we are talking about the big H, so, and this is specific heat, specific enthalpy, so we need to times the mass, the mass flow rate, which is in, this is going to be in kilogram per hour. And then H2 minus H1, which is in kilojoule per kg. So at the end, it cancel, we're going to get kilojoule per hour. Okay, so just put in all the value. We have 1000 and then 2200 minus 165. We are going to get 203,500 kilojoule per hour. Okay, but normally we are going to change into SI unit, and SI unit hour should be in second. So we going to times 1/1 hour, 3,600 second. So at the end, we're going to get the final answer of 565.28 kilojoule per second. So at the end, we're going to get the final answer already. So question number 1 is very simple, is very easy. Similarly, like the closed system, what you need to do is to just list down this formula first and determine which one that we can consider as zero and which one that we need to calculate. But for me, as what I always stress, especially during the mass balance, is for you to prepare a flow diagram like this so that you can have a clear and better picture about the process. Okay, so let's just do question 2. A fluid flow through a turbine. Okay, turbine at the flow rate of 45 kg per minute. Okay, so ada juga dia punya M dot dia. Across the turbine, the specific enthalpy drop of the fluid is 580 kJ per kg. So it's a drop. So this is delta and it's a specific enthalpy. So it's not big H, it's a small h. Or H with caret. Okay. This one. And the turbine lost 2100 kilojoule per minute in the form of heat energy. So this is Q. Q and it's from the system of is lost. Bila lost, then the Q will be in negative or positive. It's lost by the system, lost from the system. So it's a negative or positive value there. Anyone can answer? Positive ke negative?
Negative.
Negative. Okay, thank you. Determine the power produced by turbine. Power, we are referring to W lah. Okay. Produced by the turbine. Assuming the changes in kinetic and potential energy may be neglected. Okay, dia dah terang-terang cakap kat sini. The kinetic and potential energy may be neglected. So, senang kerja kita. Okay, so for the second question, this is number 2. Okay, first of all, lukislah dulu turbine. This is a symbol of turbine. Normally turbine macam ni. And then this go in and this go out. And what the value that we have M dot, which is 45 kg per minute. Sometimes we purposely did not put the unit in the standard SI unit. We want you to do some unit conversion. And then what else that we have? We have the heat loss. Q, which is negative 2100 kilojoule. Okay, what does that the question asks? Oh, okay. Okay, and the Q is in terms of rate, ya, ada titik because it's per minute. Kan? Per minute, kan? So just be alert with all the unit, okay? So what they want is W. How much is W? Okay, first of all, okay, another one is the change of the specific enthalpy or the change of H, which is equals to negative because it's a loss, okay? Drop. Bila drop tu maknanya the H2 is smaller than H1. In the calculation of data H, calculation is data H is H2 minus H1. By considering they say it's dropped, so that's why it's negative 580 kilojoule per kg. So this is all the this is all the information that have been given in the question. So first of all, just tulis balik the general equation equals to Q plus WS. Okay, and the question already stated that Q, PE and KE and PE can be considered zero. Okay, so now we want to know the WS. We have Q, we have delta H, so it's very easy. Okay, and the one that we have now, the unit, okay. Q and M is in term of rate. Dot plus. So W pun dia kata, sekejap jadi soalan dia. The power produced by the turbine. So the power should be in watt ataupun kilojoule per second. Yeah.
W2 supposedly to be negative.
What?
WS2 supposedly to be negative.
That's supposedly to be negative. Turbine loss. Determine the power produced by the turbine. Okay. Kalau the one is will be negative, kan? Sebab dia produced by the turbine. Produced by the turbine. So it's produced by the turbine because of the system. So the system will produce the power, the work. So the work will be negative. Okay, thank you. So this will be negative. Negative. Okay, thank you. Tak apa. So this is delta H. Okay. So what we need to do, we need to make sure that the unit, in order for us to solve this, okay, so this is W lah. So Q minus delta H. Yeah. And then we want to make sure that the unit now. Okay, so Q is negative kan? Negative 2100 kilojoule per minute. Okay, minus delta H. Okay, but we have what the one that we have is a specific ni. So we need to multiply by mass flow rate. Okay, this is M dot times delta H. Okay, so the mass flow rate is 45 kg per minute times delta H, which is negative 580 kg, kilojoule per kg. Itu tulisan. This one is kilojoule per kg. Okay. So we can cancel this, and then it's going to be kilojoule per minute. Sama lah. So at the end, you're going to get negative you're going to get how much? 45. You're going to get 2,400 kilojoule per minute. Betul tak? And then we can change minute with per second. 1 minute is equals to 60 seconds. So we are going to get 400 kilojoule per second. Okay, so this is also equals to 400 kilowatts. Because our watts equals to joule per second. So we are going to get the final answer 400 kilowatts. Sama tak dapat dia punya jawapan awak? Did you get the same answer? Did you do the calculation?
Sama rata.
Sama. Okay, good. So that's question 2. Now we are going to do question 3. A rotary air pump is required to deliver 900 kg of air per hour. Okay. So this 900 kg per hour is the M. Okay. And the enthalpy at the inlet and the exit of the pump are 300 and 500 kilojoule respectively. The air velocity at the entrance and the exit. So now they are giving us the air velocity. When we have air velocity, that means that we have some kinetic energy, because kinetic energy is half mu kan, velocity. So ni 10 and also 15 respectively. The rate of heat loss from the pump is 2,500 watt. Determine the power required to drive the pump. Okay. So sama juga for this one, the question asks us about W. Okay. So let's just try to solve this question 3. Okay, so we have pump. Okay, this is a symbol of a pump actually. Bulat lepas ada tempat bawah. This is a standard symbol of pump. Okay, so this is inlet and this is outlet. The mass flow rate is 900 kg per hour, and H1 specific enthalpy is 300 kilojoule per kg, while the velocity one, small one, is 10, small u is 10 meter per second. Okay, and then we have the H2 of 500 kilojoule per kg, and then we have U2 equals to 15 meter per second, and then some heat loss here, Q. Bila loss, that means it's negative, 2,500 watt, or equals to 2.5 kilowatt, or equals to 2.5 kilojoule per second, because watt is equals to joule per second. Okay, so we have this information. Similar like the previous one, what we need to do is to list down back the equation, the general formula, equals to delta H plus delta KE plus delta PE. Okay, so in this case, Q we have, and then the question asks about WS, and then the enthalpy definitely will be there. Kinetic energy, because we have the velocity here, so the only thing that did not stated anything in the question is the potential energy, the height. So that's why I consider the potential energy as to be 0. Okay, so the one that we have, all of this is in the specific value, yeah, per kg, per kg, per kg. So in order for us to calculate, what we need to do is to times with the mass flow rate. Okay, Q plus WS equals to mass flow rate times. Okay, for the delta H is H2 minus H1 plus, okay, for the kinetic energy is U2 power of 2 minus U1 power of 2 divided by 2. And all this, okay, this, okay, tak apa. So, macam ni Okay, so we, please try to see the way the unit had been calculated. So, nanti kau tidak awak confused. Kenapa macam ada tambah dia ni semua So, I'm going to just put all the value with the unit. 900 kg, the most flow rate is 900 kg per hour times the H1, H2 is 500 minus 300, and this is in kilojoule per kg. Okay. And then plus, okay, so we have velocity 1, which is velocity 2, 15 power of 2 minus 10 power of 2, and this is in the unit of, dia bagi dua, sorry. This is in terms of the unit of M, because it's power 2, M2 per S2, divide by 2. Okay, so like this. Okay, so how we going to solve this? Because we have different unit. This is kg per kilojoule per kg. This is meter meter square over s square. So this is where we have to do some calculation in order to change the unit. Okay. If you notice, kg m2 s2 is equals to joule, kan? So kalau meter s2 is equal to joule per kg. But we want to change to joule per kg, but this is kilojoule per kg. So kilojoule per kg is equals to m2 s2 times 10 power of 3. So that's why what we need to do now, this is in order for us to change M2 S2 into kilojoule per kg, this have to times 10 power of 3. So this is already kilojoule per kg. Okay, so when the unit is already the same, we can solve it. 900 kg per hour times 200 plus 0.625 kilojoule per kg. Okay, so from here we are going to get 18056 2.5 kilojoule per hour. And then we want to change it. This is still Q plus W. We want to change this so that it's going to have a kilojoule per second. So 1 hour is 3,600 seconds. So we are going to get 50.16 kilojoule per second. Okay. Saya tambah sebelah Okay, once we have this, okay, rewrite by the Q plus WS is equals to 50.16 kilojoule per second, and then the Q will be moving to the other side, 50.16 kilojoule per second minus ni positive minus, and the value of the Q is already in minus, so it's 2.5 kilojoule per second. So we're going to get the final answer of 52.66 kilojoule per second, which is equals to 52.66 kilowatts. So this is the final answer for question 3. Anyone any part that you confused ke? Especially this one lah. You need to make sure in order for you to do the calculation, it's not straightforward. It's not straight away you just put in the value and then you can straight away do the calculation. No. That's why the first part of this subject is to for you to understand back and refresh back about the unit, so that for you to calculate the whenever you do the calculation, you need to make sure that you did not forget about the unit. Okay. But I'm just going to give you tips. Whenever you have any kinetic energy and also potential energy, normally this is the way to change it. Selalu macam ni lah. Don't confuse macam alamak, macam mana aku nak terfikir macam nak ubah unit ni semua. Tapi normally it's going to be like this, because normally for the velocity will be in meter per second. So definitely it's going to be in meter power of 2 over s power of 2. So this is the way to do it. So what you need to do just to times divide by 10 power of 3 in order to get the kilojoule. Yeah. So don't worry about it. Even for the potential energy also will be the same, more or less the same. We are going to do it in the example 4. Okay. So for example 3, okay, everyone? Boleh ya? Senang je kan?
Doktor, nak tanya yang Q tu negatif kan? 2.5.
Yes. Q is negative. So that's why bila kita kita movekan Q ni bila movekan ke sini kan dia akan tolak. We have to minus. And the value is already in negative, so that's why we jadi plus lah. So 50.16 plus 2.5. So that's why the final answer will be 52.66. So bagus. It's very good for you to alert with the signs, positive or negative. Okay.
Dekat slide 3 ada doktor tak change.
Apa dia?
Ada slide 3 tu doktor tak change negatif. Saya rasa lah.
Yang mana? Ni Oh, this one ke? Ke slide mana ni? Q.
KJS. Ada.
Okay. Oh ni. Oh, okay. Sorry. So this should be negative, this should be negative. Okay. Sorry sebaik. Okay. Kadang-kadang this kind of silly mistake will cause you some miscalculation. It started with negative, suddenly when I changed, the negative sign left behind. So you just going to take the value with the negative sign, then at the end the calculation will be error. So please make sure that you, whenever you do the calculation, please be very particular and very detailed about it. Thank you for reminding me. Okay, so question 4, this is the final question for today. The power output of an adiabatic steam turbine. So apa maksud adiabatic? Anyone remember? Ni kalau tanya dalam soalan test ni sedap ni. Maksudnya apa? The system is insulated without any Q can penetrate in or out. So no Q in equals to 0, Q out is also equals to 0. So that's mean that this is that Q is 0 lah, more or less. Okay, the power output is 5. Tapi we have the power up the work which is 5. Okay, dia lukis pun kat sini. Okay. So we have the power output is 1 megawatt. Okay, megawatt nanti we have to change to kilojoule per second. Okay. And then the inlet and the exit condition as indicated. Okay, so we have all of these question, all of this information. Now the first question is to compare the magnitude of delta H, delta specific enthalpy, specific kinetic energy, and specific potential energy. Okay, and very interesting because now for the question 4, all the element in the general equation need to be calculated because we have the pressure, we have temperature, we have velocity, we have height. For P2, pressure, we have X2, which are, okay, so this is the mass fraction. Whenever we have this, so we need to consider about the way to calculate the based on the mixture of the gas and the liquid. Okay, the velocity V2 100 ni, and also okay, so we have 10 and then 6. So based on this, okay, so let's just try this. This is more interesting because for this one we're gonna have to consider all of the calculation. So lagi panjang sikit lah jalan kerjanya. Bila panjang tu lagi menarik lah. Okay, so I'm just going to draw again. Okay. Betul ke? Dia terbalik saya lukis. Betul lah. Okay. So ada W W out from the system. So it should be negative megawatt, which is equals to 5 times 10 power of 6 watt. 5 times 10 joule per second. Okay, and then what else that we have? We have P1. Then this is inlet, this is outlet. P1 is 2 megapascal, which is equals to 10 power of 6 Pascal. Okay, and then we have T1. Okay, now we have temperature here. You see, we have V1, velocity of 50 ms, and then we have the Z1, magnitude of 10 meter. Okay, don't get confused. Sometimes they use Z, sometimes they use H for height. So don't get confused with that. But definitely when it comes to do with height, definitely this is something related to potential energy. P2 equals to 15 kilopascal. Ni tukar kepada kilopascal tak ya. And then X is 0.9. Bila X ni, that means that the substance have a mixture of liquid and vapor. V2, velocity 2 is 180 ms, and then we have Z2 equals to 6 meter. Okay, banyak ni. Okay, so it's okay, tak apa. We try to solve one by one. The first question asks about the magnitude of delta H, delta KE, and delta PE. So we start with delta H first. Okay. Delta H. How to find delta H from this side and this side? Nak bagi ni. Delta H is equals to H2 minus H1. Macam mana nak dapatkan H2 dengan H1 ni di sini? We have the P, we have the T, so we need to refer to steam table. Okay, so which steam table that we can refer to in order for us to find the enthalpy? Steam table mana ni yang kita nak tengok ni? Kita ada pressure, kita ada temperature. Which one? Okay. Kalau macam ni, when you see something like this, it's good for us to go to table A4 or A5 first. Okay, so let's just go to A4 lah, A4. A5 lah. A4 lah. Okay, temperature 400. We go to A4, temperature 400. Ada tak? Oh, tak ada dalam ni. Kat sini table A4 sampai 373.95 je. Okay, what about the pressure? 2 MPa is equals to, kalau MPa maknanya 2000 Pascal lah 2000 kilopascal lah. Kan? 2000 kilopascal kan? Ada tak 2000 kilopascal? Ada. When you see jumpa tak dekat A5? For the P of 2000 kilopascal, what is the temperature there? Is 212.
212.
So, boleh tak guna value kat sini? Tak boleh. Disebabkan the temperature is higher than the stated temperature stated in the table. So, this is the sign that we need to refer to table A6. And that means that this is saturated, superheated steam. Sebab selalunya lah, if you notice, if you got pressure and temperature, selalunya kalau if you want to refer to A5 or A4 punya table, we only been provided with either temperature or pressure. But if we been provided with these two properties, then most probability, the high probability that it's about the superheated steam, and we have to refer to A6. So please go to table A6 to find H2. And I want you to also ni for the steam table, please practice about the interpolation on how to calculate the value if it's not stated in the table. We have to do interpolation. So for H1 equals to berapa tak? Dapat berapa? Anyone can ni H1 for ni at 402 megapascal. Berapa value dia? H. Berapa? Anyone?
3248.4.
3248. 32. 3, mana tadi? 3248. 48.4 kilojoule per kg. Okay. So H1 pula. Okay, H2 dah settle. For H1 dah settle. So for H2 pula, how can we calculate the enthalpy? Macam mana cara nak dapatkan? Kita ada pressure kat sini kan? Kita tak ada temperature kan? And then we have the X, which is the quality. So ini yang macam saya ajar tadi, kejap tadi, berkenaan dengan cara untuk dapatkan the enthalpy or the specific volume or the specific internal energy whenever we have the fraction here. So H2 will be HF plus X HFG. So this is referring to table A5 lah. Sebab dia pressure. Betul tak? So if you refer to table A5, 225.93 times 0.9 times 2372.3, we are going to get H2 equals to 2361 kilojoule per kg. So we have H1, we have H2, so we can calculate the delta H. So delta H is equals to 2361 minus 3248.4. So we are going to get negative 887.4 kilojoule per kg. Why negative? Why negative? Boleh tak negatif? Persoalannya. Is it possible for us to get delta H as negative value? Yes, of course can. It depends to the process. If the inlet is superior in terms of the enthalpy compared to the outlet, for in this case, this is turbine. Faham? Awak boleh bayangkan turbine tu macam mana? Do you know what turbine is? If you have like turbine to generate electricity, and the steam will pass through the fan of the turbine fan, and the turbine fan will be macam berpusing tau. And this pusingan, it will produce the kinetic energy and potential energy, and it will rotate the shaft, and this shaft will be linked into the electromagnetic punya part where it will, like dynamo tu, and then it will generate electric. Because of this. So the inlet, the steam inlet will be very high in the temperature as well as the enthalpy, but after it's reaching after dia dah proses nak pusingkan the turbine tu, and then the outlet, definitely the energy will be lesser lah, because some of the energy has been converted into the kinetic energy and so on. Jangan baca soalan turbine tapi awak tak dapat. Cuba bayangkan what the turbine is and how it works and how it operates. Then you're going to get a clear picture. So that's why the data here we got negative. And then after that, we want to calculate also the delta KE. KE is V2 minus V1 per 2. There's no M, because this is a specific apa tu? This is a specific KE, so it's already have M. Sorry. Betul lah. It's already have M in it. Okay, so we have berapa dia punya ni? V2 adalah 180 minus 50 bahagi dengan 2. This is in meter per S2. Okay. Tapi kita we want to have our energy in kilojoule per kg, because this is a specific KE. So what we need to do is to change. Again, similar like the previous question here, as I mentioned before, kita nak dapatkan the from M2 S2 to change to kilojoule per kg, we need to have this conversion. So for this one also we can do it. 1 kg per kilojoule per kg is equals to 1000 M2 per S2. So we are going to get at the end 14.95 kilojoule per kg. Okay. So this is for the kinetic energy. Okay. Don't forget about the unit conversion, especially when it comes to the kinetic energy as well as the potential energy. Okay. So this is for the kinetic energy. What about the specific potential energy difference pula? PE. Okay. So gravity times Z2 minus Z1. Okay. So 9.81. The unit is meter per second. Okay. 6 minus 10 meter. So bila buat ni jadi ni kan M2 S2 kan. So we need to also change the unit with 1 kilojoule per kg, 1000. So for the potential energy, the final answer is 0.04 kilojoule per kg. Okay, so dapat tiga-tiga all the magnitude of the three ni lah benda yang dicari ini. Okay, bila ni I baru teringat the what? The lecture on mechanical energy kan ada part example yang I give you GC, gravitational constant tu yang 1/3 something 32 ke benda tu. So this is also play the same role in which it will be used in order for us to standardize the unit. Because especially when it comes to the English unit, kalau awak tengok balik dekat that example 17.2 ke apa, ada saya introducekan GC. Teringat tiba lah yang tu. Okay. So now we have these three. The question asks determine the work done per unit mass of the steam flowing through the okay. Determine the work done per unit mass. Okay. Well, actually the work done is already been stated, 5 megawatt. But it want us to have it in kilojoule per kg. Okay. And for us to change, this is in, okay, this is specific. This is in rate. 5 megawatt is equals to berapa tadi? Kilojoule per second. Okay. In order for us to change this to this, we need to know the mass. Because kalau tidak kita tak ada ni, kita tak boleh change from this to this. But actually the work is already been stated here. But in this is one of the way, but we don't know the mass. In order for us to directly change this, the mass flow rate, tak ada. But it's okay. The other way that we can do is to do the we can do the general equation. Okay, so this is for B. Okay, so Q plus WS equals to delta H plus delta PE plus delta KE. We already have all of this value. Q is considered 0, so WS is negative 887.4 minus potential energy is 0.04 plus 14.95. All of these are in the same unit, kilojoule per kg. Cuba tengok balik. We already changed all to kilojoule per kg, kilojoule per kg. Okay. So WS in terms of kg will be negative 872.454 kilojoule per kg. Okay, why dia negative? Sebab this from the system, dia daripada sistem kan. The work had been done by the system to the surrounding. So tenaga telah dikeluarkan daripada sistem, sebab tu dia jadi negatif. Okay. And lastly, question C. Calculate the mass flow rate of the steam. Okay, barulah kita nak cari mass flow rate dia kan tadi. In order for us to solve this. But we don't have it, and now we can now change. We can now calculate the mass flow rate because we already have the specific work and also the work rate. Okay, so ini sepatutnya dengan ni WS is equals to nah macam ni. So M is equals to W over WS, which is 5,000 per S times 872.454 kilojoule per kg. So we can change this. So at the end, we are going to get 5.73 kg per second. So this is negative, this is also negative, so it's going to be positive. Okay, so at the end, for the mass flow rate is 5.73 kg per second. Okay. So, okay tak? For this one. So this is the type of question that will be asked in the final, So ada panjang sikit ni, and we have to refer to the table, steam table. It's not just the for the first until the third question, just a direct calculation. But for the final exam nanti later, I will integrate with the steam table. You have to find the steam table for you to do the calculation, as well as for the test too. Okay, so please familiarize yourself with the steam table on how to get there and which table to use for which question. Okay. What else? Okay. Question. The flow rate kan, for instance like this one kan, M.1 and M2 sama ke tak sama? Sama ke tak sama? Because we now calculate the mass flow rate tau. Dia tak cakap dekat in ke out. So maknanya dia ni. Kenapa kita kena consider this is sama? Because this is we are just referring to a steady state process. Bila steady state process, the volume, the mass in is equals to mass out. So bear that in mind. If it's about the unsteady state, later in the more complex, not for the subject, we are just focusing on the steady state process, but maybe for other subject that you're going to study about the unsteady state, the mass flow in and out will be different. But for this one, the mass flow rate is the same throughout the whole process. But considering just going to focus on the steady state process only. Okay, any question related to tutorial 4? Okay, so if no question, I think that's the end of our tutorial session today. I wish you all the best for your tests, and please be prepared for your test next week for this subject. The thing that will be covered is up until, well, actually it's a closed system. Tapi ada sikit yang part open system, which is the, about the X, the quality tu. Mana tadi? Okay, ni for the open system, the quality will be included in the question up until ni lah. Example 15.2. Okay, starting from here dah tak ada. So please prepare yourself for the test. I give you ample time for you to prepare because I know this week you are really hectic with many tests. So next week ada lagi test tak selain daripada my subject?
Ada.
Ada? Test apa?
Static.
Apa?
Static.
Petit apa?
Static.
Static. Oh, static. Okay. So ramai juga lah ngelat supposedly sebenarnya kalau ikutkan for in terms of the ni lah, the one dekat guideline given by UPM, we have to do test 2 on week 10 to 11. So last week and this week should be in test 2. But we have to also consider lah because we have few public holiday that affect the timetable and so on. So that's why I kind of like postpone my test lah. But anyway, I also do it for your own favor juga because otherwise you will have so many tests this week and you will have more time to prepare yourself. Okay, so I think that's all for this session. Thank you so much, and don't forget about the group project ni. And I'm so sorry. I think after I did some deliberation, I think better for us to have the online session lah for the discussion like this, so that we can record this and then you can refer back to the video later.